So we're gonna simplify problem number 1. My problem came up as the square root of 80. Yours might be a little different, but it should just be one number, no variables. And we're gonna rewrite the following expression so it contains at most one radical term that does not contain any perfect square factors. So I'm gonna go through these steps when I solve. Step 1, we're going to break down the radicand into prime numbers. So remember, the radicand is this number underneath. So step 1, we're going to factor this 80. So I'm just going to go change this. And I want factors of 80. So you might need a calculator for some of these if you don't know your times tables very well. If you do, this is going to go a lot faster. But if you need a calculator, go to Desmos, and we're going to use the scientific. You can always use the graphing though if that's one you're comfortable with. So I'm just going to start dividing by 2 because 2 is a prime number. Prime numbers are those numbers that can't be simplified down anymore. So 80 is actually 2 times 40. And 2 is a prime number, so I'm going to leave that alone. And I'm going to go to 40. I want two numbers that multiply to 40. And again, if you guys need to use your calculators, just divide by 2 or 3 or 5, all those prime numbers. I usually start with 2. So 40 divided by 2 is 20. So what that means is 2 times 20 is equal to 40. And we're just going to keep going. 20 is 2 times 10. 10 is 2 times 5. So what I have here are a bunch of prime numbers. So really, the square root of 80 is really these numbers multiplied. And you can check. If I take 2 times 2 times 2 times 2, there's those 4 2's, times 5, I get 80. So all I did was I broke down 80 into 5 prime numbers. So instead of 80, I'm going to write what 80 is equal to. 2 times 2 times 2 times 5. Alright, so step 2, using the index number, find groups of identical numbers. Each group comes out of the radical as one number. So the index number here is, there's no index. So just like we said above at the beginning of our notes, if there's no index, assume that it is 2. So this is a 2. So I'm looking for groups of 2. That's what this number tells me. So I have a group of 2 2's and a group of 2 2's. So really what this is equal to is the square root of 4, and the square root of 4 is equal to 2. So when we bring out this group, it's just equal to 1 2. And I bring out this group, and it's just equal to 1 2. So this is step 2. We grouped and we brought out what we had. Step 3. Leave the leftover numbers inside the radical. The leftover is 5. There wasn't a pair of 5's, and we need groups of 2. So number 4, all numbers outside the radical are multiplied, all numbers inside the radical are multiplied. So step 4 and 5. I multiply these numbers outside, so 2 times 2 is 4, and then step 5 is multiply what's left inside. But all we have left inside is 5. So this is my answer. And I'm going to pull up Desmos just to show you. We took the square root of 80 and we simplified it into 4 square roots of 5. So I want you to notice that these are the same numbers. Okay, it's like reducing a fraction. We didn't change the value. All we did was rewrite it a different way. And that's what this section is. So the next problem will include some variables, then it'll have both numbers and variables. But we're going to follow these steps every time.